Welcome to the VoltMagic instructional video. My name's Win and we'll be going over the VoltMagic RC monitor. VoltMagic has three basic functions. The first is voltage, and that's the voltage of either a battery or a BEC or a voltage regulator that is the power supply for the servos in your model. The second function is called peak low voltage. That is the minimum voltage that your power supply goes to when it's under load. The third function is glitch detection or fail-safe detection. That's where VoltMagic is looking at the servo pulses coming out of your receiver. Okay, before we actually configure a VoltMagic, note that voltage is not constant. Whether you have a battery or a BEC or a voltage regulator, voltage is going to dip when the servos move. And if the servos are under significant torque for a long period of time, they're going to draw current for a longer period of time, and there's going to be a longer and perhaps deeper voltage dip. Voltage is not smooth, but VoltMagic smooths it out. What you really want to know is this voltage up here. The VoltMagic algorithm is going to indicate this voltage for your battery voltage, and it's going to trap this for your peak low voltage. Okay, VoltMagic has 20 ranges. Before we decide what range we're going to use, let's define what a range is with VoltMagic. A voltage range allows you to shift the scaling of the trigger points for the LEDs up or down appropriate for the voltage of the battery or voltage regulator that you're using with your model. Now on the board, we're going to show a discharge graph here of a 2-cell LIFE pack right here. And we'll pick range 14. The blue lines represent the trigger point for the first yellow LED. And as we can see, range 14 is just a little bit under 6.5 volts. So now let's configure it. Alright, we've set the transmitter for channel 8 to be VoltMagic, and we've set the endpoints for plus and minus 85. Okay, it's plugged into channel 8. We're going to apply power, and then to get into configuration mode, we're going to wiggle the switch that's tied to channel 8. The configuration mode is indicated by LED 1 blinking. According to the instructions, we're looking for LED 2 and 6 on for range 14. There's LED 6 and there's LED 2. That is range 14. To save it, we simply turn the power off. When we turn power on, we're going to get the startup display, and we're going to end with LEDs 2 and 6, which is our current configuration for range 14. Now we're seeing the current voltage on this battery with the servos attached. Now what we'll do is we'll discharge this battery until we get just barely on the yellow LED. At that point, we'll discharge the battery fully and see how many milliamp hours were remaining at that first yellow LED trigger point. Alright, we've discharged our battery down to where we're on the verge of hitting the first yellow LED. We've got 5 digital servos attached, and we're going to turn power on just like we're getting ready to go fly. We've got our test pattern displayed. After she comes up, we're going to stir the sticks, as we always should do on a little pre-flight. So we exercise the battery just a little bit, and notice that we have a peak low voltage indication, 1 green blank, which corresponds to 5.4 volts. And if I look at the oscilloscope, that is 5.36. Now if the peak low voltage indication comes on too early, you can shift it to low range peak low voltage, and we'll do that for you just to demo it. We're going to turn power off, turn power back on, flip channel 8 back and forth, and what we're looking for here is LED 1 is going to go to a very fast blink right there. See how it's blinking faster? We turn power off to save that configuration. We turn power back on, and now if we stir the sticks, We're not going to register any peak-low voltage at all in low range because we've shifted that peak-low voltage scale down 0.4 of a volt. Now what we'll do is we'll discharge our battery and find out our milliamps remaining. Okay, for future reference, it's a good idea to take a loaded voltmeter reading on the battery before you do this discharge test. As you can see, the test is done and we have 381 milliamp hours remaining on this battery. Voltmagic can also detect glitches and fail-safes. A glitch is a long, a short, or a missing pulse. That is the default setting, and it's what most radios are going to use. High-end radios can set a fail-safe position for individual channels, and in particular the channel that Voltmagic is connected to. If your radio can do that, you can configure Voltmagic to detect fail-safes as well as glitches. And here is an example right here. And the other thing that Voltmagic does is that it memorizes these particular events. So we have a glitch showing up here. And let's just say we also have a peak-low voltage. And it's there and it's showing. And if we cycle the power, when we first turn the power back on, we're going to see those displayed back to us during the first 5 or 6 seconds of operation. And that's so that, you know, if anything happens, it's like a little black box that's inside your model, lets you know what happened. All right, I think that does it. I want to thank you for watching, and we're on the web at voltmagic.com.